All right, for posterity, this is the practice exam number 2 in fall semester 2023. So that said, let's get into some stuff. I just said it a moment ago, but I'm going to say it for the recording. The exam covers worksheets 5, 6, and 7. And by points, it's roughly 30% on simplifying trig identities and 70% on graphs of sine and cosine. Oh no, it's definitely worksheet. Yep, cool, excellent. Chat had a question, but we covered it. All right. So without too much more ado, let's get into it. So question number 1. We want to determine the exact values of A, B, C, and D so that the graph below matches the function. So it's basically, here's a graph, find an equation for a sine or cosine that fits the graph. So as I've said a few times, sine and cosine have the exact same wave function for their graph. The difference between a sine and a cosine function then is just where we start. But if we're choosing our own starting location, we could make this graph be either sine or cosine, depending on our choices. For this particular problem, I'm going to say we're going to find a cosine function, just because that's what is listed in the problem itself. On the exam, I'll do the same thing. I'll tell you specifically which of sine or cosine I want you to find. You can go from there. But so since it's a cosine function, that means our starting values have to be a maximum or a minimum. So our starting locations for cosine could be this point, or this point. That being negative 5 pi over 12, negative pi over 12, or pi over 4. Any of those 3 points are going to be valid starting locations for cosine, and you can find an equation that starts from any of those 3. I'll choose just one once it comes down to it, but you could choose any and you'd still find the correct answer. Because all of these graphs of sine and cosine are cyclical in nature, meaning they have a repeating pattern. They go through cycles, which is where cyclical comes from. So again, we could pick any one of those 3 points and find a cosine equation starting from one of those. But okay, let's start reading stuff from the graph. First couple of things. I would always start with the range, just because I think it's the easiest one to start with. I just need my minimum y value and my maximum y value. My minimum is down here at negative 5, while my maximum is at negative 1. So my range, negative 5 to negative 1. I can use the range to find both my amplitude and my vertical shift. The amplitude here is going to be 2, while the vertical shift is negative 3. I'll go over the work for that in just a second. But if you're comfortable with it, just from looking at the range, I know that the amplitude is going to be half of the range. So from negative 5 to negative 1 is a distance of 4. The amplitude is half of that, so it's 2. And the vertical shift is the midpoint of the range. So right in between negative 5 and negative 1 is negative 3. If you're comfortable solving it out that way, great. And if you'd prefer a more formulaic way of calculating those, then go with the following. The amplitude is negative 1 minus negative 5 divided by 2, which comes out to 4 over 2, which is 2. And that's how I'd get there. Keeping in mind that those two numbers both came from the range. So I'll mark them in purple. Then for the vertical shift, how about VS for vertical shift? It'll look pretty similar. -1 plus -5 over 2, which would be -6 over 2, which in turn is -3. Where again, both of those numbers in the numerator are coming from the range. Cool. So all of that I can get just from the range itself. Hi. So the question was, will you need to show all of that work in order to get full credit? And no, you won't. If you want to jump straight to 2 and -3, it's fine by me. I did it. I think you can do it too. Yeah, that's just for if you don't see how to get the numbers right away, fall back on the formulas. But yeah, you do not need to show all the work for those two. Yeah, cool. So that's everything that we can get just from the range. So next from the graph, we should read the period. And in order to get the period, I need to look at the distance between two similar points within a cycle of sine or cosine. What I mean by that is usually look at the distance between two maximum values. So the start of one cycle compared to the start of the next cycle. If I look at the distance between those 2 points, that'll get me the period. As long as I've got a decent enough grid and a large enough section of the graph, I can always go between two maximums. If I don't have a ton of the graph, so like if you look at this, I have barely more than one cycle, which means that those are really the only 2 points I'm going to be able to use to get my cycle, to get my period effectively. We'll probably look at an example after this one, or we might have to get the period a different way. But for now, just look at the distance between two maximums. So the question was, would it come out the same way if we just looked at the distance between two minimums? And yes, it would. Yep. Any two like points within the cycle, I could calculate the period between. So I need pi over 4 minus -5 pi over 12. In order to do that subtraction, I'll need a common denominator. So pi over 4 is 3 pi over 12 plus, oops, I missed a negative over here, didn't I? There it is. Plus 5 pi over 12. Add that up to get 8 pi over 12. And simplify that to get 2 pi over 3. 2 pi over 3. Why did you start from right to left? So in order to calculate the length of that period, the length of that cycle, I want my final point minus my initial point. So I did right minus left. If you did the reverse, left minus right, you'd still get 2 pi over 3, but it would come out to -2 pi over 3. Which, I mean, that work is just as valid as long as you know that you need to take the absolute value of your answer when you're done. Because the period won't ever be a negative number. Question? Oh, yeah. Yeah, absolutely. Yep. Yeah, so another way to have calculated the period here would be like this. I can count 1, 2, 3, 4, 5, 6, 7, 8 boxes in between my initial point and my second point. All right, so in between those two, there are 8 total boxes. So to get that period, I could have also done 8 multiplied by the length of one box, which is the x scale. I believe our x scale is pi over 12, which would be 8 pi over 12, which is also 2 pi over 3. Yeah, also a totally valid way of getting it done. As long as your, scale is nice enough. I know we've seen some examples where there were like 20 boxes in between the 2 points. You could still count up 20 multiplied by the x scale. That just gets to be kind of a pain. So it all just depends on the grid you're looking at. Both are valid ways. Both will always work. It's just a matter of which one's easier. Then I saw in chat, will we need to simplify in order to get credit? I'd say for the period, you probably should. I think it'll be easier if you simplify. But I'm not going to focus a ton on simplification on these graphing problems, because I know that when we actually go to do the x scale, if we're graphing our own, it is oftentimes easier to not simplify that x scale. So I'm going to be pretty lenient on simplifying on these graphing problems. All right, what have we not done yet? Phase shift. So I mentioned right at the beginning that there are three valid options for the phase shift on this graph. We need to pick just one. And I'm going to say picking pi over 4 is going to be the best option, or the option I'm going to go with. You could have also picked negative 5 pi over 12 or negative 1 pi over 12. Either one of those are valid options for the phase shift as well. But I'm going to say it's usually easiest if you pick a value where a is positive. That way you don't have to deal with a negative a when you're putting the question together later. So either of the two green points that I circled will come out to be a positive a value, because those are the maximums. And if I chose instead to start at the minimum, starting at the magenta circled point, that would make a negative instead of positive. Say it one more time. Yeah, for cosine, any peak will work. And yeah, I'm going to recommend choosing a peak instead of a value. It's because it makes your a easier. Hi.
So when I did this, for some reason, I thought it was a sine instead of a cosine graph.
Gotcha.
So I got my phase shifts as negative 5 over 4 and pi over 12. Would that work if it was actually a sine?
Yeah, it would. Okay. And in fact, the equation that you get would be the same graph that I get. The equation would just look a little different. Yeah. Cool. So can you explain more about the phase shift? Sure. So when we're trying to read a graph to get the phase shift, our phase shift is simply going to be our starting location. So we just have to pick some point to start our equation, to start our graph, and then measure out from there. So for cosine, it always starts at its maximum value or its minimum value. So I just have to choose any maximum or minimum to be the starting location of my cosine graph. And if I were doing this for sine instead of cosine, I would be choosing any point along the middle line. So anything along the line y equals negative 3. It's right in the center of the graph, because sine starts at its center and then moves up or down. So again, phase shift is just our starting location. And because this is an infinite cycle, there are an infinite number of starting locations we could choose from. So if you wanted to get real fancy, you could find a phase shift that's not even pictured on the graph, and you'd still get it right. But let's not do that. I can't plan for every single phase shift that's out there. So I'll just plan for like 3. Okay, we have to put all this stuff together. So oh boy, come back. Come on, don't do this to me now. Pen died again. All right. You can just pull the battery out, put it back in. I'm sure it'll be fine, because that's how it works. Yeah, there it is. Nope. Oh. Okay. A is plus or minus 2. Since A will always be either positive the amplitude or negative the amplitude, because I chose one of my green phase shift points, A is going to be positive 2. But if I had chosen one of the magenta ones instead, or the only magenta one, A could come out to negative 2. B, I need 2 pi divided by the period, which in our case is 2 pi over 3. Here's where simplifying the period is going to be nice, because it's going to make this math easier. So this is 2 pi over 1 times 3 over 2 pi. And that simplifies to 3. So I'll put that in the box. Let's check going on about. Show the phase shift again. Yeah. Yep, they're up here. Yep, the 2 green circled points were the positive phase shift options, and the magenta circled point is the negative phase shift option. But again, I decided to go with pi over 4 because I thought that would be the easiest one. Hi. You do not. Nope. Just choose the one that you're going to work with and only write that one down. So the question was, for the video later, in case you can hear that, was do you have to write down every phase shift? And no, you won't have to write them all down. Just choose the one that you're going to work with. Now, on the online exam, I think there's a question that asks, write down every possible phase shift for a cosine graph on this function. But it's like, that's the whole question. When it's part of a larger graphing problem like this one, only write one down. Hey there.
I'm a little confused here because when we find the period, we're doing 2 pi divided by b. So how are we finding b by dividing 2 pi by the period?
Aha, so question was, when we were doing the original stuff, when we were going from an equation to a graph, we got the period by taking 2 pi divided by b. Now to get b, we're doing 2 pi divided by the period. And let me just do a quick aside over here. So b is 2 pi divided by the period. I'm going to use capital T for period because that's a common notation for period. If I were to solve this equation around to get period instead of 2 pi, just multiply T over to the other side. So I get the product of the period and the b value, which is the angular frequency, is equal to 2 pi. And then just divide b over to the other side. And we get 2 pi over b. So the equations look very, very similar. And it's just because the product of the period and the angular frequency is always 2 pi. Why is a positive thing not negative? Question mark. Okay, so why is a positive and not negative is what I think that question is. And yeah, the next person in chat had it exactly right, because we chose to start at a maximum value, which is why a comes out positive this time. If we started from a minimum instead, would have been negative. Oh, yes. So the question was, even though the maximum is a negative value, a still comes out positive. That ended up being a statement instead of a question, but it's a true statement. So yeah, even though the maximum value is positive, the a value, or even though the maximum value is negative, it's -1, a still comes out positive. The reason for that is that our vertical shift is a larger negative number than our amplitude. Vertical shift is -3, and the amplitude is only 2. So we only get to -1. But I got derailed for a while there. I mean, I digress. Back to C. So C, I need B multiplied by the phase shift. I'll use PS for phase shift. So that'll look like 3, which was our b value. We have to solve for b first before we get c. Multiply that into pi over 4. And that's 3 pi over 4. 3 pi over 4. And finally, d, which is the easiest one. D is just the vertical shift. Nice and easy. -3. So -3 goes right there. And finally, just put it all together. So this should be 2 cosine of 3x minus 3 pi over 4 minus 3. So don't forget that c is, we're subtracting c on the inside of our sine or cosine function. And that'll even be given to us in the form of the equation itself. So up at the top, cosine of bx minus c. So c always has the opposite sign of what we see. C has, yeah, well, haha. Homophones are fun. Haha, yes, this is being recorded. Cool, so that was our equation. Some other options we could have gotten. We could have had a 3x plus 5 pi over 4. No, it'll just be plus 5. No, 5 pi over 4, yeah. If we had chosen -5 pi over 12, we would come out to 3x plus 5 pi over 4 instead. If PS equals -5 pi over 12. And you could even do another one where it came out to 3x plus 1 pi over 4 if you'd chosen -pi over 12 as your phase shift. But that's more if you were, just if you did the practice exam first and you chose something different from what I did, it might look like that instead. But that line at the top, this is what our answer is equal to. That's our answer. Oh, the answer. Okay. All right. Let's pick up the pace. See if we can finish this in time. Okay, so multiple choice. Which of the following is the best graph for y equals 9 sine of pi over 2x minus 6? Okay, so what are we looking at here? So in broad strokes, trying to decide which of these things make more sense. I have a negative phase shift and I have a positive a value, and my amplitude is bigger than my vertical shift. Hope I said vertical shift the first time. That's what I meant to say. So I need a graph that's been moved down, but since its amplitude is bigger than the vertical shift, it should still come back up above the x-axis. So I can start by getting rid of a couple of these. A and D are both out because that vertical shift was negative. We actually put that in the color that we always use for vertical shift. Right, and both graphs of A and B were shifted up. If I go look at my amplitude value, since it's 9, it's more than 6 is, which means that this thing should be moved down, but it'll still come back up above the x-axis. So C doesn't make sense either because it's too short, leaving just option B. Even though I can't really read the scales on there, relative to the x-axis, I know the only valid option is B. Cool. All right, then let's take a look at this graph. So which of the following is the best function for the graph shown? 5 different options for sine. They all got the correct amplitude of 2, but some of them have a positive value and some of them have a negative value. So let's start there, because that might be the easiest way to determine what we're looking at. This graph starts at 0 and then moves down. All right, so from its starting position, I know that this thing is a negative sign graph, meaning all of the positive sign equations are out. None of those are going to work. I need a negative sign graph to start this one, as long as I'm not going to work with a phase shift, which if I'm starting from the origin, I might as well not use a phase shift. So I just have to figure out the correct option for B. So B is 2 pi over the period. So I should go figure out what that value is. Now, because this is sine, I'm going to read my period along the x-axis. I'm going to read it along the center line. I don't have 2 maximums, nor do I have 2 minimums on the graph as shown. So I'm not going to use that to calculate the period. I'll instead go along the center. And keep in mind that if I'm going to measure my period from any point other than the maximum or minimum, I'm going to need to skip over a point in the middle to get a full cycle. So if I had just gone from 0 to that looks like 2 pi over 5, the point in the middle, I'd only get half of my cycle. I'd only get the downswing of the cycle. And the cycle needs to include the full piece. It needs to include a downswing and an upswing. It needs both a peak and a valley. So my period here should be 4 pi over 5. So 2 pi divided by 4 pi over 5. Run those numbers real quick. 2 pi over 1 times 5 over 4 pi. And that simplifies to 5 over 2. So option D has the correct B value, the correct angular frequency. Yeah. Oh, hey, speaking of, list all phase shifts on this graph. Forgot I had this question on here. List all phase shifts where the value of A is positive in the equation. The f of x equals cosine A cosine bx minus e plus d. So we've talked about this one already. Our 2 options for positive phase shifts are there and there. Pi over 4 and negative 5 pi over 12. And for the sake of completeness, if the question had instead asked us for negative cosine, then the only phase shift we can see is negative pi over 12. That was the function for the last question. I think it was sine, wasn't it? Yeah. It was option D, negative 2 sine of 5 over 2x. Or 5x over 2. Heard it both ways. Right. Then the next one, if we just ask about cosine, let's ask the same thing about sine. So here's an option, list all phase shifts where the value of A is negative in the equation A sine bx minus c. So since I'm doing sine, it'll be helpful to have my vertical shift line on here. And it looks like it's this yellow line here. So if I want the options where A is going to be negative, I need all the points that intersect this yellow line and immediately start moving down. So those options are that point and that point. Those are the two that would come out to a negative sine function. So this guy over here on the right is at pi over 2. And over on the left, I believe that's at negative pi. So those would be my two options for a negative sine function. And for the sake of completeness, and since we've done it on all the others, come back. A positive sine function would be here at negative pi over 4. But for negative phase shifts, I get those two options: positive pi over 2 or negative pi. Why not negative 7? So if I chose a minimum value, like say this guy right there, that would be a negative cosine function. And I'm looking for negative sine. So don't choose that one. Yeah, 115. All right. So, hey, what's up?
So just to confirm, so like, because it's a sine, we're only considering what's on the vertical shift, right? Is that how we find this kind of shit?
Yes, exactly. Yep, because I'm asking specifically for a sine function, we'll only consider phase shifts that fall along the vertical shift. Yep. Yeah, good question. Okay, 15 minutes. I'm going over on time for sure. Okay, from an equation to a graph. Let's do that. The options, I've got A is right here. It's 7, B is 6. C is negative pi. Right, it's always got the opposite sign of what we see. And then D is negative 3. Let's take all of that and figure out what all the other stuff is. Period, amplitude, range, phase shift, and put a graph together. So the period, 2 pi over 6 is pi over 3. So pi over 3. I won't care if you show the work on this one. But if you get the number wrong, there will be partial credit if you do some correct work. That's always a decent idea to show work, but not strictly necessary. It's just riskier not to show your work. Let's get the amplitude. I need the absolute value of 7, which is just 7. Not a lot to it there. Getting the phase shift is C over B. So I've got negative pi divided by 6. So negative pi over 6. No simplification to be done there. And let's go get the range. So the maximum and minimum y values. I'll start from 7 and negative 7 and add my vertical shift. So subtract 3 from both of those numbers to get 4 and negative 10. So that's my range. Make that a little bit smaller. My range was negative 10 to positive 4. And then let's go get the x scale. The x scale is always the period over 4 because there are the 4 quadrants. So pi over 3 divided by 4 is pi over 12. So our x scale, pi over 12. And now that I've got my x scale together, I'm going to come back up to my phase shift and get a common denominator. So negative pi over 6 is the same as negative 2 pi over 12. That way my phase shift and my x scale have the same denominator. It'll make it a lot smoother when I try to put my x scale together. Hi there. One more time. Gotcha. So question was, for the phase shift, y was c negative pi. Because if you look back in the equation, it says 6x plus pi. Valid question. So anytime we've got one of these sine or cosine transformation functions, the inside is always bx minus c. So c just has the opposite sign of whatever we see. Which if you think back to linear transformations from like an algebra class, the inside was always the opposite of what you'd expect. So like big numbers on x actually will shrink the graph, whereas small numbers will make it stretch out. For the horizontal shift, negative numbers move it right, but positive numbers move it left. So everything on the inside is just a little bit backwards. But yeah, so c was negative pi. All right, let's put our scales and subsequently our graph together. So I'm going to start by plotting my phase shift. Or at least putting it on the graph. My phase shift was negative 2 pi over 12, or negative pi over 6. So I'm going to write that down as my first point. It's going to be left of the x-axis. From there, count out 4 tick marks, keeping in mind that the y-axis is probably going to be a tick mark. At least if you start to the left, it will be. So 1, 2, 3, 4. And then count forward by our x scale. This next one would be negative 1 pi over 12. Add pi over 12 again to get 0 pi over 12. And then positive 1 pi over 12. And then 2 pi over 12. So that should be my x scale. And no, let's go see what chat's asking about. Yeah, perfect. Chat answered its own question. Yep, the x scale is always the period divided by 4, since again, we have those 4 quadrants. Oh my. Ooh. And no, I won't care about simplifying the x scale. In fact, I think it's easier to not simplify the x scale. Keeps our denominators consistent. Right, so we got all that on there. Let's also come down here and numbers are a little big. You shrink them a little bit. Cool, good enough. Our vertical shift was negative 3. So I'm going to draw that line in, like y equals negative 3, and say that that's our vertical shift, and then put the rest of my y scale down. I know that my range was negative 10 to 4. So those are the other 2 points, or the other 2 labels that I'll put on my y-axis. So once again, we're at the point where we actually need to put our graph down. And up until this point, we have not cared if we had a sine or a cosine function because the setup up until this point is exactly the same for both. So at this point, I should go check to see what kind of function I have. And I have a positive sine function. A is positive 7, and my function is sine. So I want to run through my cycle starting from sine, or with the sine pattern to get through it all. So I'll go right here. Say this thing is positive sine x, or say that I'm starting from my middle because I have positive sine x as my base function. Our motions go through our cycle. If it's positive sine, we start at the middle and then we go up to the maximum, then back to the middle, go down to the minimum. Means I'm going to move my label over to the right side of the axis, down to the minimum, and then back to the middle. Those are my 5 key points. Then I just need to put the graph down. Go up to here. And then back up to that point. And that's my graph. Let's go see what chat's on about. Okay. Yeah, so it looks like we were talking about some algebra in chat. So yeah, when we're dividing by 4, that's the same as multiplying by 1/4. Someone had that correct. Yeah, all right, and then I had the question, why did I start the graph at -2 pi over 12? So let's deal with that. Because yeah, that is indeed where I wanted to start my graph. 2 pi over 12 simplifies to negative pi over 6. And that was my phase shift. Negative pi over 6 or -2 pi over 12 was my phase shift. And the phase shift is always where I want to start my graph. It's where I'll start my single period that I'm graphing. So starting at the phase shift, if you'll notice, I've labeled the phase shift in magenta every time. So you can kind of follow that color through the problem to see where it ends up. And then, yeah, we should continue labeling our key points. Negative pi over 12, 4 up here. We have a point at 0, -3. So we'll label that. We got positive pi over 12, -10. And then finally, pi over 6, -3. And again, I'm not going to care too much about whether or not you simplify when you're creating a graph. Especially on the x scale. Oh, I think it's better to leave it unsimplified, which means when you list your key points, I won't mind if you don't simplify. I always will if I'm giving you a graph, because I'll put a simplest form. I'll put a simplest form answer on there. So you need to be able to recognize the simplified answer, but I'm not going to care if you actually do the simplification. There's a slightly easier scale, I think. Oh, good. We're gonna. Oh nope. We're not gonna finish on time. I'm gonna come back to problem 9 after I do problem 10. So I want to make sure I get to this problem because it's the one. I think this one's more similar to what you'll see on the exam. But these should be the last 2 questions. Whole bunch of stuff on graphing, and then hey, look, the trig identity, everybody's favorite. So let's get through this thing as best we can. So what do we want to do here? Step 1, It's the same step on every single one of these trig identity problems. Deal with any angles that are not simply x or theta, whichever one you're given, or t maybe. I'm pretty sure I used x when I wrote the exam, but won't matter what letter is in there. Just make sure it's the same letter in every single trig function. So things I want to deal with first are, let's go mark them. I want to deal with this cosine of negative x. I want to deal with that cotangent of negative x. I want to deal with that cosecant of pi over 2 minus x. So I'm going to leave the rest of it alone. Well, I'm going to say I'm going to leave the rest of it alone, but then I'm going to do one more step. But starting from here, that plus tangent x is hanging out right there. I'm not going to deal with that, but I will deal with the rest. So just let's go in order from left to right. I've got a cosecant of pi over 2 minus x. Pi over 2 minus x is the complementary angle to x. So if I have the complement, I want to use the co-function. Pun doesn't really work. But they both start with CO, which is how I remember that they go together. So I need the co-function of cosecant, which is co-cosecant, or just secant. Co-cosecant isn't really a thing, but I like to think it is. So I need cosecant of pi over 2 minus x becomes secant of regular x. Yeah, okay, fine. Be that way. I have a stop it. There we go. Okay. Oh my god. Okay, hang on 1 second. Gotta do the thing. Blow on the battery. Pens overheat in the modern age, apparently. Hey. Okay. Almost. Ah, there we are. Okay, and then we're going to add to that the other fraction. Dealing with cosine of negative x and cotangent of negative x. Well, cosine is an even function, meaning cosine of negative x and cosine of positive x are the same thing. Negative inputs don't matter to an even function. But for cotangent of x, which is one of our odd functions, negatives do matter. So that negative on the inside, I'm going to pull out. Cool, so that dealt with my 3 angles that weren't simply x. Normally, I'd say that's a good first step, but I need to hurry up this example. So I'm going to combine one more step into the first part and say that if I have square trig functions, I probably want to use a Pythagorean identity. So this one, I've got secant squared minus tangent squared. That is just equal to 1. I'll put that step in here too. All right, up next, let's get things out of the denominators. So cotangent, I'm going to bring it up. And same with secant. I'm also going to bring it up. Using some reciprocal identities. So this will look like 1 plus tangent x over 1 multiplied by cosine x over 1. Since secant and cosine are reciprocals of each other, let's slide that a little bit over to the left. I'm going to simplify my multiple signs on the right side. I'm adding a negative fraction. So this will become minus cosine x over 1 times tangent x over 1. I'll highlight that x in red to emphasize that It came from our cotangent in the denominator. Cotangent and tangent are reciprocals. Hi.
Where's the negative go?
So that negative is the same red negative you see on the line below. I just put it out in front of the fraction. Then I'm going to distribute that cosine across the numerator. I said across the numerator. There we are. To get cosine x plus cosine x times tangent x. Cosine x tangent x minus, on the other side, I also have cosine x tangent x. But then I can see I have a plus cosine times tangent, cosine x tangent x minus cosine x tangent x. So that adds up to 0. So the only thing that survives is cosine x. Again, sort of plus 0 over here. And that's what we were trying to show. So this thing was equal to cosine x. So I know we're over on time. So if you got another class to get to, feel free to go do that. I think I can finish up the next problem in like 5 minutes. So I'm going to stick around and do that real quick so it gets itself on the video. But again, if you have somewhere else you got to be, I know we're already 4 minutes over. So I'm not going to be upset if you leave. I'll upload this video later. Also worth pointing out, here to the right side, I had another solution to the problem where I changed everything to sines and cosines. If you prefer that method, it works out just exactly the same way. But it's all right there. Okay. Then at lightning speed, because we gotta finish this up. Let's go through this problem, number 9. The professor for the next class is always late, so it'll be fine. Okay, real fast. Cosecant of pi over 2 minus theta is secant of theta. Cosine of negative theta is cosine of positive theta. It's an even function. Tangent of negative theta is negative tangent of theta. And tangent of pi over 2 minus theta is cotangent theta. Hey, Veer, you are welcome. And good luck on that exam tomorrow. Yeah, it's tomorrow. Up next, secant is 1 over cosine theta times cosine theta minus tangent theta times cotangent is 1 over tangent theta. So that simplifies to 1 minus 1, which is 0. That's probably a pretty simple answer. Let's go check the box. And anytime I'm listing out a ton of answers, 0 and O will always be the same thing because they look identical. So came out to 0, which is option O. The next one down, I've got secant squared minus secant squared of theta minus tangent squared of theta. That is 1 divided by 1 plus cotangent squared. That's cosecant squared of theta. And that is sine squared of theta. I bet that's a simple enough answer. Let's go check the box. Hey, look, there it is. Option H. As I said, I had O earlier. So let's circle that. H is that one. And lastly, secant negative theta times tangent pi over 2 minus theta. Secant of theta, secant of negative theta is just secant of theta. Tangent of pi over 2 minus theta is cotangent theta. Since I need a co-function identity, change this all over to sines and cosines. 1 over cosine theta times cosine theta over sine theta becomes 1 over sine theta because those cosines cancel. And I'm left with cosecant theta. So let's go check the box for that. So I think that's a simple looking answer. And it is indeed in the box. Option E. All right, and I got us through the whole practice exam. So thanks for sticking around. If you did, yeah, I'll just check chat, see if there's anything else I should put in the recording, or if we're going to be done. Okay, not regarding the current question. What would the negative phase shifts be on a negative cosine graph? So for negative cosine, you want to pick all of the phase shifts that are at the minimum value. So the bottom of the valleys. All the minimums are negative cosine phase shifts. What's going to be on the in-person exam? A few graphing problems and one big identity like the last problem. So expect to have to graph both sine and cosine and read at least one graph to sine or cosine. And the identities will not be given on the exam, so you'll need to have them memorized for the in-person part on Thursday. But of course, the online part's open note, so you're good there. All right, and I am going to pause the recording.